Welcome to Chapter 6, the Chatelier's principle. The third factor of the Chatelier principle that we will be discussing is addition of inert gas at constant pressure. So we will be looking at constant volume and also constant pressure. For constant volume, there will be no change in partial pressure of gas. Thus, there is no effect on equilibrium position for constant volume if we add noble gas. However, at constant pressure, there will be change in partial pressure of gas. Thus, if we add noble gas, it will affect the equilibrium position. So let's look at constant volume. Before adding the inert gas, the total pressure of the system is given as such. So when we add in the noble gas, this is the new total pressure. Let's look at the animation. So the volume remains the same. Although the total pressure of the system has increased, the partial pressure of gases at equilibrium do not change. So just a reminder. PV equals to nRT. So what we have here is P equals to nRT over V. Now because V is constant, it will not affect the pressure. And then one more thing is we keep the volume constant, not the total pressure constant. So there will be no change in equilibrium position. Now, the one that will affect the equilibrium position is at constant pressure. Before adding the inert gas, the total pressure of the system is as such. So after we add in the total pressure, see what noble gas. Let's look at what will happen. For the new one, this total pressure and this total pressure must be constant. However, for example, this is 2 mole. This is N2O4 is 1 mole. Then the P total equals to, let's say, 3 atm. Now we say the condition set at constant pressure, meaning that this is also 3 atm. But now we have 3 gases, N2O4, NO2, plus noble gas. So meaning that in order to maintain it 3 atm, the same as this, the earlier one. So the whole thing here, initially I put it as, for example, 1 atm, 2 atm. So here is initially 1 atm, 2 atm. So I can no longer put 1 atm, 2 atm anymore, because otherwise, when noble gas add in, it cannot be added. So what happened is maybe I need to reduce it. For example, maybe this one I put 0.5 atm. This one maybe I put 1.5 atm. And then noble gas 1.5 atm. So we can see here, it has reduced from initially equals to 1 to now have to reduce to 0.5, 0.15, because we add in noble gas and in order to maintain the constant pressure. So if pressure has to be kept at constant after adding the noble gas, one thing will happen, that is the volume of the vessel has to be increased. So the equilibrium position will shift to the higher number of mole. Why? Because when volume has to be increased, when volume increase, pressure decrease. Okay, or we can see here also the pressure has decreased. Okay, so meaning that when we add inert gas at constant pressure, the disturbance is the partial pressure of gases at equilibrium has decreased. That's why we need to have shift to higher number of moles. Okay, now let's continue with an example here. Okay, the question here is, the disturbance here is adding inert gas at constant pressure. Okay, so just look at the reversible reaction equation. Okay, so first of all, we know this is 2 mole, this is 1. So total 3, this one is only 1. So reactant has more moles, product has fewer moles. Okay, so remember when inert gas is added at constant pressure, the partial pressure of gases at equilibrium decreases. So according to Chatellier's principle, equilibrium position will shift to the direction which has higher number of moles. Okay, so if we look at this reversible reaction equation, when adding in inert gas, okay, so the partial pressure has decreased. So we need to increase. Okay, so when we add in inert gas, the partial pressure has decreased. So when we need to go back to equilibrium, we need to increase the pressure. Okay, increase the pressure, we look for more mole. So the equilibrium position will shift to the left with more moles. Okay, so just to remind again, remember when we add inert gas at constant pressure, the equilibrium will shift to direction of higher number of moles. Okay, so that's all for adding inert gas at constant pressure.